Hey, there we go. I have audio now. Let's try that again. Good evening. Welcome to episode 22, Jeremy Makes Stuff. This is part 4 of our Wi-Fi controlled piano player thing. Still hadn't come up with a good name for it yet. When last we talked, we had taken a 3D scan of the hand, this one actually, cleaned it up a bit, picked the finger we wanted, added the fingernail, added some knuckles, and that was about our deadline last time. But I wanted to show you, I imported it into Blender. This will open here, and I used Blender's rigging system, or armature system rather, to add bones. And you can see here there's a bone there and a bone there and a bone there. And I was able to, because before the scan the actual model was straight, like a straight finger, but now with the bones I was able to give it a curve. And there's, you know, it can curve on any different axis, some curves that fingers shouldn't do, but I was able to give it a nice curve here, as you can see in this perspective view here on the top right, where it's more of a curve where the normal human finger would be type. There's not a good it's just too straight, because for it to push down, it's gonna have to start way up high. So added some bones, posed it just right, and I exported the model back to Mesh Mixer and cleaned it up again, smoothed out some of the edges and stuff, because it took the mesh and it actually bent it, so there was some stretching with the triangles and whatever. So I cleaned that up real good, and see if this was the right one. That's his hand. That might not be the right one. Oh, there it goes. Oh, okay. Delete the hand. So here is a set of 10 fingers in the slicer that, you know, ready to go. I haven't 3D printed them yet, because I still need to figure out a little more about the hardware and how the finger is going to connect to the motors. So right now the model just has a flat bottom, which would be great for printing, but you know, we still have to figure out how it's going to connect to things. I may end up putting a hole there and using like a piece of coat hanger or something. I don't know yet. We'll figure that out. But so we've got those finger scanned, model cleaned up, basically ready for 3D printing until we figure out the next piece of that. So what I wanted to do tonight, and the episode title talks about programming the ESP8266. Now, I have an ESP8266 right here. Let me switch this way. So I have an ESP8266. This package is actually the Node MCU, which it's got the ESP8266 right here, and the rest of this is just for programming it, and it's got the pins broken out for like a breadboard. It'll plug in real easily. But I have a bag of the just naked ESPs. I don't know if I call it naked, but they're not connected to the programming board. But I want to program on this one first to make sure, you know, it's easier just over USB to program it, test it, you know, and iterate that way. And then once that's set up, we'll continue testing with this one, with the breadboard and the different motors and whatever in next couple episodes. But eventually what I want to do is use just the ESP8266 without the breakout board, and but we'll get to that later. But for now, I have the ESP8266. We're going to work on that, and then it's going to connect to an Arduino, which will then control the motors. So first, I followed, let's see, you can kind of see it here behind me, a little smaller. There's a really good tutorial here on 42bots.com from 2007 that talks about how to get the ESP8266 set up for the computer. So I'm going to follow along with this tutorial a little bit. I've done it twice before, so it's not too bad, not too difficult to run through. Switch back over here, and we'll get this started. So like I said, I've got the ESP8266. It has a USB port on it. I've got a cable somewhere. Here it is. Plugged into the laptop. So the first thing I need to do is install the Arduino IDE. Close Blender. To do that, I'm going to go to arduino.cc, software, and downloads. And I've never used their online web editor before. I'm not going to do that right now either. I'm going to download, yes, exit Blender. I'm going to download the Windows installer. I don't really know why I would want to use the Windows app version versus the Windows installer. But I'm just going to use the Windows installer. And for now, I'm just going to download. You can donate if you want when you go to download this. It's a open source software. And it's what, 106 megabytes. It's here behind my head. 106 megabytes. Downloading here. Grab my water a little closer. Now, the Arduino IDE is great for programming Arduinos, but it will also program the, you can use it to flash the code that we write to the Node MCU. Fire up the installer. And I agree. Yep. On my D drive. And it's going to install some stuff. And this will come with a bunch of pre-built libraries and things already for the Arduino, as well as some sample sketches and all of that. And the Arduino IDE is actually based off of the processing IDE. And processing is a pretty cool visualization language library thing from the Processing Foundation. It actually comes on Raspberry Pi as well, and you can get it for Android. And there's even a JavaScript version. I've done a few things with it. It's really cool, very visual, and everything in it is, it's a lot of math stuff, and it's really easy to take what you do in processing and put it into a different language. I had made a processing sketch before that had a bunch of moving things that were connecting and various stuff happening. I was actually able to port it to the Arduino, and because it was just math, so that was pretty cool. And then you just had to swap out, you know, I'm drawing a circle using this method instead of this method. But anyway, the Arduino IDE is based off of the Processing IDE. It looks very similar, and we might do something with processing later. We'll see. It's really cool. It's really fun to play with. So the Arduino setup completed. Hit close, and I'm going to open the Arduino IDE. Now the ESP8266 does not. It's by default, it's not available under the boards. It's here now for me because I had previously installed it, But I'm going to show you how we go about that. So it's possible to get different board types, and Arduino IDE can be used for other boards as well, and the manufacturers will provide a URL with some information. So go here into preferences, and then network, settings. Here it says additional boards manager URLs. And I have 3 in here right now, or 2 in here right now rather. And this one, arduino.esp8266.com/stable/package_esp8266com_index.json is the one that has the ESP8266 board information. So then, I've already got that there, but once that's there, you can go to Tools, Board, and then Board Managers. And then this pulls in all the different boards from whatever URLs are in there. And here you can just search for ESP. And right here is the ESP8266 by ESP8266 Community. I have version 2.4.2 installed. There's also 2.5 betas and some older versions. It's possible that whatever version of ESP8266 you're working with, it may require an older version, or there'll be new features on newer versions or whatever. So, like, I'll show you here. I'll remove this one. And then if you want to select one to install, there's just an install button. And it downloads whatever files it needs, and it's there. So then under Tools and Boards, here's all the default Arduino boards it comes with, and under here are more, some ESP8266 modules, all these different things. And you can see here there's different, here's some from Adafruit, the Feather, some Espresso boards, Node MCUs, SparkFun, Sweet Pea, Wemos, all kinds of cool stuff. So the Wi-Fi Arduino. So I know that this one is the Node MCU 1.0. Now if I didn't know, I could just use the generic ESP8266. But I know which one this is, so I'm going to select that. And I'm going to plug this in, and it will be detected on a COM port. Oh. Is it there? Okay. And check tools, COM port 3, selected. And I'm not going to change any of these other details here, upload speed, CPU frequency. These are all different options that it could change, or, you know, depending on which device, microcontroller you're using. This is a little loose in this cable here. Let's see how that works. Okay. So that's basically the setup bit of it. Have the software installed, the device is plugged in and detected. So that was pretty simple. So now, let's see, I'm going to switch screens here. And let's look here. Some interesting stuff here on 42 bots. Here they've got some examples of a couple of different devices. But down here it's talking about the pin mappings. So there's all these different pins, not just on the ESP8266, but you know, for the Arduino or Raspberry Pi or whatever. There's all these different general pin IO, GPIO ports, and on this one they're broken out. That's why it's got the little bug legs on the side here, so that it can be plugged into a breadboard. But this is the basic layout, showing here's all the different pin positions. So here's digital 0, digital 1, etc. through 10, There's a couple of ground pins, 3.3 volts. Here's a 5 volt in, another ground, reset pin, you know, a bunch of different stuff going on here. Here's a clock. And so there's these different MSOI, etc., different serial ports and all that kind of stuff. And some of these pins, you know, can be used different ways. Like here, digital 7, it's GPIO 13. It's also the receive pin for a tertiary serial port. And I'm not sure what HMOSI is. So that's probably the input for the fourth pin is there. But anyway, the I could have zoomed it a little, I guess. A little bigger picture there. Yeah. Oops. Mouse is a little jumpy. Where'd the picture go? There we go. So it's basically the layout of the little guy here with the pins. So and they're all labeled here on the board as well, D0, D1, D2, just like it is on the screen there. So let me flip back here and you can see, maybe get it lined up just right, and if it'll focus, it's not focusing, but right along the inside line here of both sides of the pins, it's labeled the same, D0, D1, D2, D3, D4, etc. So you can easily look at it and identify which pins you're meaning to use and what they're for and all that kind of stuff. So back over here. Whoops, I clicked on the picture. Go back. There we go. So that's just, you know, the various pins. So if I wanted to hook up motors directly to it or sensors directly to the ESP8266, I could do that. For this project, we're not going to do that. The ESP8266 is going to communicate with an Arduino over serial port, I think. We'll see when we get there. We're not there yet. Let me flip back over to the laptop. So the next step here is we want to make sure everything's working. So 42bots.com has a demo blink sketch, and I copied that, and it was a literal copy paste from the web page. You can see, you know, here's the page with the schematic or diagram, whatever, and then down here this is their block of code that copied and pasted into its own sketch here. I just want to step through this. I'm not sure, I don't think I can zoom in on that. Let me do that over here then, and kind of walk through the code first and see what's happening. And I'm just gonna disappear for a minute. Alright, so first there's this big comment block here starting with this /star. It's just some information about this the sketch and where the pin mapping diagrams from and all that kind of stuff. So right off the bat, first thing, there's this LED pin and it's set to D0. Now remember, back up here on the diagram, D0 is this GPIO pin. So what that's saying is this pin is going to be connected to an LED. And the variable name doesn't necessarily matter, other than us knowing, you know, what that variable is for. So LED pin. Next, inside the setup function, initializing the LED pin as output, because it's going to send a signal out and cause an LED to turn off or on based on whether there's power being sent. And then next is the loop function. And what the loop function does, it literally loops through this forever until it either loses power, is reset, in which case it goes back to setup, or there's some other ways to call the functions and stuff, but there's not really an exit condition here, in this case anyway. So right off, and then it's going to do digital write LED pin low, so it's turning off the LED pin. And then it's going to wait 1 second, and then it's going to tell the our LED pin high, so it's going to turn the LED back on, and then wait 2 seconds. So it's like 1 second on, 2 seconds off, 1 second on, 2 seconds off. So let's flip back over here. So that's this code here. So here's the LED pin, set to output mode, turn it off, wait a second, turn it on, wait 2 seconds. So right here, this is a verify button, and that makes sure there's not any syntax errors in the code before trying to upload it to the device. So for example, if let's say this didn't have the opening comment thing here and I hit verify, there's going to be an error compiling because this wasn't really declared correctly, and when it tried to use the LED pin variable, it didn't work. So I'm going to put that comment back. I'll hit verify. It's compiling again. And done compiling. It was successful. It shows how much space it's going to use. So the ESP8266 only has so much space on it for the programming, and this particular program is going to take up 23% of the space. So I am going to hit upload, and it's compiling again. Now it's uploading. Oops, upload memory failed. I think this wire is too loose. Let me switch USB cables here with my front light. My light uses the same style USB cable. Let me turn the light back on. Oh, maybe. USB cables never go in the correct way the first time, even if it's oriented right. I'm not really sure how that happens. Alright. Turn that down just a little bit. That's better. Alright, so new USB cable. Try this again. Hopefully this will be a snugger fit. More snug? Snugger? I don't know. Oh yeah, that's a solid hold there. So let's try this again. Upload. And if you watch here, while it's uploading, the LED is flashing to show that there is activity. %. You can see the little progress bar filling up there. 64. And here's 100%. Oh, 97. Now we're at 100. So now the LED should come on for 2 seconds and then off for 1. Hold up a little bit higher so you can see the LED. There it's on, now it's off. Or sorry, on for 1 second and then off for 2. No. Off for one, on for two. I don't know. Oh, I get it. Huh. So the onboard LED is the opposite of what the pin signal is. So if there was another LED connected to D0, it would be off when the onboard LED is on. So yeah, here it's off for 2 seconds and on for 1 second. So it's a little confusing, but it's just the way the LED is set up here, and I'm not wired up to another LED like the tutorial is requesting. So anyway, that worked. The code compiled, and we uploaded it to the ESP8266 on the Node MCU. Okay, so that's cool, but the big deal about the Node, or the ESP8266, is it's a Wi-Fi chip. So, there's a couple of different things that we can do there. First of all, for our project, we want it to host an access point that we can connect to and then control the final device. So there's actually two different examples that 42bots.com goes through next. First, it's just creating an access point. And this is pretty cool because it uses the ESP8266 Wi-Fi library right here. And let's see, is there a way to zoom in? I don't think so. Increase font size, Control plus. Yeah, there we go. So I'm gonna make this bigger. There we go. Now we can see it. Okay, so this code here, what's happening, so we're using the ESP8266 Wi-Fi library. It's going to create a network with an SSID that we give it here. So default here is ESP8266. Let's call this piano player. And then it wants the password. For now, we'll say 1, 2, 3, 4, 5, 6. So setup is going to run the first time. It's going to wait a second. Then it's going to open the serial port with a baud rate of 115,200. So with the Arduino IDE, there's actually a serial monitor here where we can debug by looking at the commands, and we can even send commands across. I mean, right now, sending a command with the blink sketch isn't doing anything. But, so we'll actually see feedback from the device, and it'll say it's configuring the Wi-Fi access point. And that's so serial.begin creates a serial connection. Print ln, print line, it's just like a carriage return. The print function, then you can pass it in text or variables or whatever to display. So here it's just saying configuring Wi-Fi access point. Now here it's using inside the ESP8266 Wi-Fi library. There's this soft AP. Excuse me. So it tries to create an access point with the ESP8266. And this comment here says you can remove the password parameter if you want the AP to be open. Now, in our case, I don't want to do that, but you never know why you may want to have an open access point with some device on your network or whatever. Seems I've lost my camera again. Oh, there we go. Okay. So, I'm going to leave that here for now. Whoops. I'm going to leave that here for now. So next, if the access point is successfully created, so it's being passed into this result variable. So it's going to try to create the access point. If it's created, then we're going to set up the, we're going to get the IP address of the access point, basically the router at this point, right? It's the ESP8266 acting as the router. And I'm not sure why I'm having camera issues. So I have to mess with that stuff later. Anyway, so it's retrieving the IP address of the ESP8266 as the router device, and then it's going to print to the serial port. Wi-Fi network name is what we told it is, piano player. What the network password is, and then what its IP address is. Now, if for whatever reason creating the access point fails, so if result is true, it's going to print out that stuff. If it's false, it's going to do a serial.print error, something went wrong. And then inside the loop function, every 3 seconds, it's going to print out number of connected devices, and then it's calling this soft AP get station num, which is another function inside the Wi-Fi library, and it will tell us the number of clients connected to the network. So hopefully that wasn't too confusing there. Oh, this %d is for a digit, so it's going to do the number there. I didn't change any of the code here. I'm going to verify. Well, change the SSID and the password. Compiling the sketch. Alright, it's just going to use 24% program storage. I'm going to upload, and this will start blinking really fast. And I'm going to open the serial monitor. You can see the little progress bar going on down here at the bottom. 31%. 63. 95. There we go. Alright, so here in the serial monitor, there was an error. Something went wrong. Well, I don't know what it is, but let's see if that network exists. ESP8266. That network shouldn't be here because we changed the SSID to piano player. That's interesting. Alright, I'm going to connect to it and see what happens. The previous password was ESP8266 capital T test. I'm not sure what Windows 10 is doing. Let's see. I'm going to... Okay, it says I connected. So apparently it did not accept the network name change. But let's go back to the serial monitor, and it shows that there's one station connected. I'm going to connect from my phone as well, and we should see that 1 turn into a 2. Yeah, right there. So now it says there's 2 clients connected. So my phone's connected and the laptop's connected. I wonder why. I just disconnected my phone, so it says 1 again. I wonder why it didn't take the username and password change. Let's see here. Maybe it's because I didn't. It shouldn't. I mean, I changed the code. Compiling it, it shouldn't matter if it was saved or not. But I think it saves it before it compiles. Try that again. And I want to close the. Okay, the serial monitor is closed. Upload memory failed. Connected on COM3. Try again. Let's see. We'll close these other windows. And let me disconnect from that network. Sometimes whenever the ESP8266 is running, it actually has to be reset before it'll take a new bit of code too, I think. That one more time and see what happens. Okay, it's uploading now. That was strange. So you can see here it actually compiles a bin file. And uploads it to the device. %. Serial monitor. Number of stations 0. I see ESP8266 again. Let me hit reset. There's a reset button on here. Configuring Wi-Fi access point error. Something went wrong. Alright, well, apparently if something goes wrong, it still has some default networking it sets up? I don't know. Maybe if I extend the delay to 3 seconds. Okay, that's why I had that error earlier, because I had the COM port open. But okay, so, or not, the serial monitor was open before. All right, kick on the monitor. Error again. Interesting. Okay, so close that. I'm gonna look up this library and see if there's maybe some information about the error we're getting. Library, yeah, documentation. PDF would be nice. Not a PDF, that's okay. So we are using soft AP. Soft access point class. Take a look here. So just doing a little troubleshooting here. Set up a network. Pass the SSID. It's minimum. You can pass SSID, password, channel, whether it's hidden or not, max number of connections. Stuff about being a client and a host at the same time. Some network interface stuff. Getting the IP, getting the MAC address. Interesting. Okay, well, this doesn't say that it actually returns a... Oh, here it is. Function will return true or false depending on results setting the soft AP. Alright, well, let's try and instead of using the variables here, I'm just going to put the string, call this test network, and the password is password. So if it prints out here, it's going to print the wrong thing because that's the variable, but that's fine, whatever. We just want to see it create this network that we tell it to create. Actually, I'm not going to give it a password. I just want an open network called test network. And the serial monitor is not opened. Opening the sketch. I've seen we've had a few viewers come in and out. Feel free to say hello in the chat. Let me know if this is interesting. If it's too deep into the code for you. If I should be using a different microcontroller. You know. Let me know your thoughts. If you have any questions, comments, concerns, etc. Okay, let's see. I'm going to hit reset so we can see the startup stuff. Oh, okay. That's strange. Worked that time with Wi-Fi network. Oh, well, not piano player, right? As I said, it's going to say the wrong thing. Let's see what... Yeah, there's test network. Huh. Alright. Try that again then with... Yeah, I'm gonna put just the SSID variable in there. Close the COM port again. And we'll see if the network piano player shows up. And I'm not worried about showing that my network name here is Coffee Cafe. That's my guest network here. So if you ever come over, maybe I'll give you the password. Oh, there's test network again. Let me hit reset. Turn the Wi-Fi off and on. Ah, there's piano player. Okay, I get what's going on. After flashing the new version of the firmware with the new network information, apparently you got to hit reset. So, interesting. Okay, so I'm going to put this back, put the password here again, which is 123456 right here. But we're using the variable password so that I can pass it in here. And when it works, it'll print it out here. And serial monitor is closed. Yeah. So I'm going to upload the sketch again. And it's uploading. Little lights blinking. As soon as it hits 100%, I'll hit the serial monitor again. So, change the delay to 3 seconds. Hit the reset button. I don't know. It could be a couple different things. This is working. We'll see when this comes up, which network it says it is. So it's an error. And this still has piano player, but it's open. So I'm going to hit the reset button here. It's an error again. Try one more time. Well, let's see. Can I connect the piano player? Or does it actually ask me for a password? Nope, I connected. Here it says stations 1. Alright, well, that's something. Have to worry about that later. This is going to be a localized network controlling our device anyway that have to be within range of, so that'll be fine for now. It's just something to remember that there's a problem we'll deal with later. So anyway, that's working, but the so the IP address, it said here, I think it said 192.168.4.1. So if I go there now though, 192.168, whoops, .4.1, I don't actually expect anything to come up because the ESP8266 isn't actually serving up a page, it's just serving up a network. So let's see what we can do to serve up a network instead. Or a page with some control information on it. So let me close the serial monitor. And 42bots.com goes into that with the next tutorial. This one here. Using the different station modes. Or, I'm sorry, the Wi-Fi station mode example. So this is saying it can communicate over Wi-Fi in 2 different modes. It can become a hotspot, or it can connect to a hotspot. And in this example, this is creating a network and then connecting. Yeah, so this is connecting to an existing network. So we're going to skip this one for now because we don't want to connect to an existing network. We just want to create one to control our device with. So must be this one. Let's see. Yeah, here we go. So this is the access point and web server demo. So in their example, they're showing the uptime of the device. They have a my mind just went blank. Come down to the picture. There we go. The light sensor chip here, and then an LED here. So with their interface, they're showing the device has been on for 2 minutes and 22 seconds. The light sensor is detecting 8% brightness, and you can turn the LED off and on. and then the page automatically refreshes, or you can click to refresh it so that you get the update on the uptime. So this is a pretty good example. We know what we're going for is close to this, right? Because we want to have a web page where we can control, or have some buttons or links or whatever to press, so that the 3D printed fingers will play the keyboard. So I've got that file copied over here. So let's walk through this a little bit. This is setting a static IP address, or defining a static IP address rather. The network name and password, again, I'm going to change this piano player, and password, let's make it Rocket Man. So this is creating a server on port 80. Port 80 is just standard port for browsing web pages on the internet. If you go to google.com, you're actually using port 80. Well, if you go to google.com, it's going to redirect you to HTTPS, which is using port 443. But anyway, this is going to use port 80. There's no SSL certificate or anything like that. Again, LED pin digital 0. LED state initially is off. And then here it has this, there's a couple of different functions here. Now previously, the last two sketches we looked at, there were only two different functions. There was a setup, which set up a bunch of details for what the device was going to do, and then there was loop, which just sat there and looped through. If you think about it like a video game, the start screen is like the setup, and you choose which character you want, and then the loop is actually every frame of the game. So you're moving Mario across the screen, you're not really moving him. As each frame ticks by, he's moving over by a few pixels, right? So the same kind of thing. We do the setup, it's handling any kind of, you know, variables or whatever we need to set up, and then the loop, it's going to loop through and run this code over and over and over. But this particular sketch, it's got a couple of different functions in it. So we have handle root, and I'm just going to walk over these real quick. Handle not found, setup, and loop. So first of all, let's look at setup. Setup, we're setting the pin mode for LED pin to be output, so the LED can turn on. Digital write LED pin to 0, so we're turning it off to start. Gonna wait 1 second. I'm gonna change that to 3. Not sure if that helped us in the last one, but we'll see. Sets up the serial port. This Wi-Fi mode, Wi-Fi APSTA. This is the like the documentation was talking about over here. The station mode. Well, I'm not actually connected to the internet now because I'm connected to the piano player network. But where did it go? Well, anyway, it's the station mode that we're using here so that we can actually access the web page that the little device is going to be serving up, so we can click the links. Excuse me. Then the soft AP configuration. This is we're looking at that over here. The SSID. I'm sorry, not the soft AP. The soft AP configuration. Give it a local IP, so the device, we know what IP address the device is at. The gateway and the subnet. It's all just networking stuff. We're setting it. It was in the example. You don't really have to understand it that much, but here it's IP address of the soft access point, the gateway IP address, and the subnet mask. Not super descriptive because the same name is in the description there, but anyway, we're setting those up. then setting up soft AP with the network name and the password, and then we're getting the device's IP address and printing it out to the screen. Then here we're setting up server.on is a function that is basically whatever, when these different things are called here, it's going to handle that a certain way, right? So if you just go to the IP address, let's see. So let me switch over here and give you an example. No, not there. Come back over here. I'm going to connect my laptop back to my real network. Probably. There we go, connecting. Okay, so right now if I go to google.com, this is going to the just slash, okay? So like this is saying here, server.on/, then it's going to call some function. These have a couple of different things going on, LED equals 1, LED equals 2, and inline. So like if I do a Google search here for cotton duck canvas fabric, you can see now it's not just slash, but it's slash search and then some other stuff. So when we go to slash LED equals 1, slash LED equals 0, or slash inline, it's going to do something different because we have all these set up. And we could add additional ones here too, right? We could do server.on and be like potato, and then have that call potato function, right? And set that up to do whatever that we want it to do. So once we get to the nitty-gritty coding part of the links for the fingers to press the keys, there's definitely going to be some endpoints that we're going to have to create here for different things, whether it's chords or single key presses or algorithms that are creating melodies or whatever. Also, I think my camera finally died, so I'll just fade out and I'll still be here with you in voice. So anyway, potato function doesn't actually exist right now, so I'm going to delete that. Let's see, then there's server on not found. That's if there's a request that's not to one of these existing endpoints, what does it need to do? So like right now, if I go to homestarrunner.com, this is going to slash in our example. If I go to let me continue on to the Flash site. So now this is going to main 1. But if I go to some gobbledygook that doesn't exist, we get the 404 message. So this is the same thing. On not found, we have to handle that. So on slash, it's going to call handle root. Slash LED equals 1, it's going to call handle root. LED equals 0, handle root. Slash inline, it's just going to send back. It's going to use the server.send, which will allow the it's just the device is just responding without doing any kind of processing or anything. So this is for quick little responses, and we'll get into some of that later. And then if it's a endpoint that doesn't exist, it's going to call handle not found. So what does handle root do? Handle root starts right here. So first thing it does, it turns on the LED, and then does some other stuff to the LED pin. We find out if the LED is on, and now here it's going to check and see if the LED is on. It's going to create this text that says LED is on and give a link that says turn it off. If the LED is not on, it's going to say LED is off and give a link to turn it on. And then here we start with some HTML. So this character array is going to be the code that the page is made of. So if I come back to, if I go to jeremysouthard.com, my website that needs updates, and actually view the page source, you can see all the HTML code here that is making up the page. So here's the home button, YouTube playlist link. So if I come over here and look inside here, YouTube playlist, you can see here's that link to the YouTube playlist, right? So same thing over here. Inside the HTML, we have, here's the title of the page, here's some styling. You know, we've done previous episodes about HTML, so I'm not going to go through and do a basic HTML walkthrough, but I will point out a few things here. First of all, this meta tag is going to refresh the page every 10 seconds. This is just in their example, right? They're showing the uptime, so they want it to automatically refresh every 10 seconds so that you can see the uptime change and the brightness value change. So that's why that's refreshing every 10 seconds. Then down here, here's uptime and %02D. This, a little further up here, see it's, there's seconds and minutes and hours are being calculated based off of the number of milliseconds that the device has been running. And this is one big giant string, started here with the quote, and these parameters here, this is saying it's going to be a digit, and this is showing that these are placeholders, because, and this might be a little confusing, and I'm sorry if I'm running through this too quickly, but these are placeholders. So here's the first placeholder, second placeholder, third placeholder, fourth placeholder, fifth placeholder. Is that the last one? I thought there was another one. But anyway, so the end of the string here, now it's the variables. So here's the hour, which would have been the first placeholder. And D means it's going to be a digit. Here's the minute, and it's mod 60. Because it's actually in seconds, I believe, from the calculation up here. I'm not sure why that's about 60. I don't know. Anyway, so this is the second placeholder. Going to show the minutes right here. And then the third placeholder is the seconds. Then the fourth placeholder. Oh, and this is showing 02 because it's going to have a leading 0 and it's going to be 2 digits long. So if it's only been up for 1 second, it's going to show 01 or 000001. If it's been up for 3 hours, 6 minutes and 4 seconds, it'll be, you know, 03 26 04, whatever I said. So the brightness, it's a digit, and it doesn't have, excuse me, it doesn't have any kind of formatting. It's not saying it's got to be 2 numbers long or 3 numbers long or whatever. So it's just taking this brightness value, whatever it is, and placing it here. And then this % is just the % after it's showing it's 8% or 10%. Next, this is a string because it's the LED text, which we were setting up here where it says if the LED is on, this LED text says LED is on, and has the link to turn it off. And see here, this is that endpoint, LED equals 0. Else, if the LED is off, the LED text says LED is off, And here's the link with that endpoint LED equals 1, where you can turn it back on. So hopefully that wasn't too confusing, and that made a little bit of sense. Let me see here. I'm gonna restart my camera application real quick, just see if it'll come up. Oh, I'm back. All right, cool. So hopefully that wasn't too confusing. With the variables and the placeholders and all that kind of stuff. But so then it calls server.send 200. That's the response code. 200 OK. It's not 404 not found or 500 error or whatever. Text HTML. This is just the MIME type. It's letting the browser know this is some HTML, some hypertext markup language. And then HTML was our variable right here. That is 1,000 characters long, or 1,000 character limit, with all the HTML code here with the values being passed in. And then it turns on the LED because the page has been accessed. Whew. What a walkthrough. Okay, but if we go to, / blah blah blah, which not is the error in any additional arguments that you pass in here, because it's going to say whether it's get or post. It's going to, just some general good error handling. If there's additional query string parameters, it's going to display those. So we'll try a couple different things and see what's going on. So then the loop function, which is the one that's just going to constantly be running, is just calling server.handleClient. So server.handleClient is waiting for a client, a computer or a phone or whatever, to connect to the website. And then based on how it tries to connect, we've already wired up the different routes here with the endpoints using the on function. So it's looping through, it's waiting for a client to connect, and then when it does, based on whatever endpoint it's trying to call, it knows to show, if there's a problem or do something. I feel like that was a little sort of rushed and frantic, just trying to get through it. We've got about 45 minutes left here, and I think we're in pretty good state. So the only thing I touched here was in the network setup. It's called Piano Player, and Rocket Man is the password. And then in the setup function, I delayed 3 seconds instead of 1 second. So I'm going to verify this code, make sure I didn't screw anything else up. The sketch is compiling here, kind of behind my head. And we'll see how much. Close one of these. I want to close the wrong one. This one I think is the old one. Yeah. Okay, so it's all of those interactions, and it's still only going to take up 26% of the space available, the programming space available. So that means we can make a whole bunch of different endpoints doing all kinds of things, which is exciting because the end goal is to have the ESP8266 be the main brain of this device. So we can plug in all kinds of algorithms and chord progressions and all kinds of stuff to then have it play at the touch of a single button. So we've got a lot of space to work with here. So that works. I'm going to hit program, or upload, I guess. Good cold water. So we're uploading the file now. You see the little LED is blinking. Whoops, which way? Over here. I don't know if you can see that right up there in the corner. It's blinking like crazy. Let's get in the code. As soon as that hits 100%, we hit the serial monitor, figuring access point, IP address, server started. Cool. So let's connect over to Piano Player. Now you see it says it's secured, so there is a password. And the password was Rocket Man. Come on, you can do it. Sometimes I feel like Windows 10 works too hard when it's connecting to a network. Okay, did it connect? Yeah, I'm connected. It's a secure connection. What is my IP address? IP address is 42.42.42.141. And the default gateway is 42.42.42.42. So let's leave the serial monitor open and go to 42.42.42.42. Hey, and there is our web page, just like in the demo here. So it says uptime is minute 55 seconds. If I hit refresh, oh, 205. If I hit refresh, we'll see that change. Brightness still says 1, and it's always just going to say 1 because I don't actually have the sensor connected to it. Like the demo tutorial has going on. LED is off. Turn it on. Now this, I do see the LED flashing, but I think there's a bug in the code. Let me see if I can get it at a good angle so you can see that. It's flashing so fast. It's like right here at the tip of my finger. Well, unless the camera freezes again. Ha! But, so it is flashing, but it's not staying on solid. That's not necessarily a problem, because we're not really using the LED for anything here right now. But, this does show, you know, we've got the uptime, we are sending commands, and you can see up here it says LED equals 1, you can go LED equals 0. Now remember, there was some other endpoints that were created. Put this over here. Let's see, there was inline, which should just display some text that says this works as well. Yeah, this works as well. And there was the not found. So let's just put some blah blah mess in there. Yep, this is file not found. Here's the URL. Method was get, arguments were 0. So just to test this, blah, let's say arg1 equals ASDF and arg2 equals 1, 2, 3, 4, 5. So that shows we called slash blah, the method was get, there were 2 arguments. I misspelled arg1, ASDF, arg2, 1, 2, 3, 4, 5. So, seeing how the not found function is handling this, I can think of a couple of different things we can do to, you know, capture the arguments that are sent and then evaluate the values and do some other things too. So that's promising. So that's working. Created a network, connected to it, and we can view the web page and do some interacting. Just real quick, just because I want to try it, I want to see why The LED is not staying on. Let's see here. When handle root is called, the built-in LED is turned off. Oh, and it's reading LED pin. Right. I don't have an LED connected to D0. Just have the built-in LED. And when the page is called, it turns off. Well, when we click the link to turn it on, it's calling the root and then LED equals 1. So that's the first thing it's going to do is turn it off. So that makes sense. Just a little logic problem there. Let's see here. Yeah. Okay. So we know why. So I wonder. We've got what? 38 minutes. Let's open up. Do I have Notepad++ on here? No. I'm going to download and install another program. Reconnect back to the real internet. So a lot of people are familiar with the Notepad program that comes with Windows. It's been around for a long time. It's nice. We used it a few episodes back. I don't know, 12 episodes or so ago to write some code. I'm going to go look up Notepad++ and download this application. Notepad++. Do you have 64-bit? Yeah, there we go. It's like regular Notepad on steroids. It has some different functions with like macros and understands different file types, so it'll use formatting and things like that. So what I want to do, that's fine. That's fine. Normally I don't put a bunch of icons on my desktop, but this time around I've just been letting stuff install here. I can always delete them later. So Notepad++, it has tabs, so I can have multiple files open at once. Unlike regular old Notepad that doesn't do that. So let's see. What I want to do is, we have this block of HTML here in our example sketch. I want to try and put together some HTML with just some placeholder information or whatever to kind of get an idea for the interface for this piano player device. So, yeah, I don't think I need to refresh either. Excuse me. Okay, so let's see. It's HTML, and we'll do head tag. This feels really small. I'm going to zoom in. Zoom in. Control numpad plus. That's pretty good. Title. Wi-Fi piano player. And make up a version number. And then body tag. Now the thing is, I can use JavaScript in here too. So I can make the interactions a little more fluid. But anyway, so let's see here. I'm just gonna say Wi-Fi piano player. The big giant words. And let me save this somewhere. Documents is fine. And this is hypertext markup language. I'm going to call this sample.html. So you can see right then it reformatted the, it's got the tags are different colors. The text inside the tags are different colors now. And as I do different things, you know, it recognizes, here it knows I'm typing a link, you know, and it highlights different sections and stuff. So Notepad++ helps better visualize what's going on here. So just with this, the title and the header, let me open that up in Chrome. Right, so it says Wi-Fi piano player, and up here in the title, Wi-Fi piano player version 0.01. So what I'm going to do then, go over here and go over here. I'm going to, let's see, for starters, let's use a button tag. No, I don't want to use a button. I'm just going to do a scale. So C, D, E, F, G, A, B, C. So C scale. Now, even though I put these on different lines, that doesn't mean they're going to be on different lines here, because white space doesn't really matter much to HTML. So I'll refresh the page here and you'll see they're all in a line, not up and down, but left and right. So show up, which is expected, because the white space here doesn't mean anything. If I did want to break these up, you know, I could put BR tags in between them. Oops. Or I could put them in a table or make them a list or whatever, right? But I think something else that's cool. Oops. If I use Alt and Shift, I can highlight a section of multiple lines and delete that or type stuff, which is pretty cool. It's a feature that is not available in regular Notepad. But for now, I think I'm just gonna do a table. And I'm gonna do, yeah, across. So a single row. And I'm gonna put each note inside of a cell. And I'm gonna use Alt-Shift do that again, tab that over. You gotta close the cell tags. Oops. Close the row. Close the table. Now I could use divs and float them, or, you know, flexbox or whatever. I'm just trying to be as simple as possible because the less HTML I have to generate, the more programming space I have for algorithms and that kind of stuff. So let's do cell padding is 5, cell spacing is 5, and border is 1. So this is going to spread them out a little bit and give a little more space in between, because what we want to do is pull it up on the phone and just have some things to press. Now, buttons may be easier than links. We can always change that later, but let's see. So suppose these are going to be single notes, so we can make an endpoint called single and give it a note value of 1 and then 2. And I'm not using the letters right now because I'm just thinking about the scale, right? It's the first note of the scale, second note of the scale, third note of the scale. It doesn't really matter what note it is or what scale it is, because this is just sort of a mock-up of how we want the final thing to look, or some semblance of what we're hoping to reach. So that's an endpoint called single, and it's passing a note value. So let's see if, using this guy as an example, all of the endpoints here, these first 3 endpoints are all handled by handle root, because it is this root slash, I guess, even though the links used a query string value. Where did it go? Here. So I'm not sure if the soft AP and station mode distinguishes that. It should, because it showed us the arguments when we went to the not found, right? Because it looped through the arguments. So I don't know, that'll have to be something to investigate later, see what's happening there. But let's see if we do void single, and let's say what was the link? Just note. Yeah, okay. So I can actually get the set of server arguments, but I don't want to concatenate them like this. So let's see, I'm gonna leave a note. Find the note parameter value. So what we can do here, we're going to loop through all the arguments. We're going to say if server.argname for I equals note, we're going to do something. Else, not really else, just that's it. We're just going to ignore anything else, right? So for now, oops, let me see what's going on here. Okay, server.arg. So then here we can say, let's set another value or another variable, set it up, be just integer, and we'll call this, I guess, what is it? It's the note in the scale. Let's just call it note. And start that with 0. here we'll say note equals server.arg. I feel like I have an extra. Nope, I'm good. It's just not spaced very well. Alright. And then let's just print that out. Where's that server.send? Yeah, so server.send, and this will be a 200 OK. And we'll send this in plain text, just like the message down here. Yeah. Oops. And send message. So here I actually need to create message. Oh, not string. It's a message, and I don't know. For now, we'll say 100. Just a message array, character array. Whoops, I don't need the. Where did I go? Just a character array, and message equals. Let's see. How do they do that up here? Okay. Do it the same way. And we will say you played the note. Note is the placeholder. It's a digit, it's note, which being set here. Now, if note is greater than 0, we'll send this. And this isn't really for real. I'm just testing out a few things here, right? And you're just kind of playing with it to see what can happen here. So let's see if the note else, let's see, server.send 404 text plain, and here we'll say you didn't provide a note to play. Single, so we need to add that endpoint. So we'll say server.on/single, and the function was just called single. Okay, now obviously I didn't update the HTML here, and that's okay. I'll just call the endpoint myself. So I'm gonna make sure I have syntax errors. Do have a syntax error. Cannot convert string to int in assignment. Oh, I didn't change the variable name. Message. Compile that again. Can't convert string to int in assignment. Oh. The server argument value is a string. That's why this line is red. That was an error too, but this is the one that's a problem. Let's see. I'm sure there's a parse function or something. Let's see. Arduino convert string to int. Oh, okay, string dot to int and then that. Okay. So it is possible that the value we are passed is not an integer, in which case that's going to be a problem as well, right? Because we're expecting the note, the number of the note in the scale. So let's try that in here. Hang on. Yeah, okay. So let me just make an inside string and call it note value. So that's going to get that as a string. And then set note equals note value dot to int. Now does dot to int return anything? Because if it returns a Boolean, then we can test it. Oh, here we go. Is digit as a function. Yeah, okay, so we'll use that. If is digit note value, we'll set note to note value dot to int. Oops, let's see. So, alright, step through that real quick. We call slash single question mark note equals 3. So we're trying to play the E. Single gets called. Initially it sets note to 0. Then it's going to loop through all of the query string arguments. And if there is one called note, it'll get that value. And if that note value is a digit, which in this case it should be a 3, it'll convert that to an integer, the string 3 to the number 3, and set that for note. And then it sets up the message, you played the 3 note, and then it outputs that with a 200 OK response. Now, if note is provided, but it's not, so there's 2 places this can stop and end up giving a 404. The first being if there is not an argument called note. The second being if there is a note, but say a letter is passed in instead. So instead of the number 3, it's the letter E. Well, the letter E is not a digit, so note is still going to be set to the default value of 0. So when it gets down here, if note is greater than 0, well, it's not. So else, it's going to return 404, error, you didn't provide a note to play. Let's see if that compiles. Cannot convert string to int for argument 1 to Boolean is digit. Oh. Because that requires the input. Okay. So I misunderstood what isDigit is doing. That makes sense in the context here. This is actually converting. This is taking an integer in, tacking it onto the end of the string, and converting it to an integer and into a string. Okay, let me see. To int. string object function. Turns along. If no valid conversion can be performed, a 0 is returned. Okay, so it's still going to return 0 if it doesn't work. So we don't need to check that. If that's a value, or if that's a digit. Which means we don't need all this mess really either. I'm just going to set... I'm all about making less code. So I'm just going to say server.arg1 or argi.toInt. So if this is a letter E instead of the number 3, it'll actually return the 0, which is the same as what our default is. It'll fall to the else. That's easy enough. Looks like that's going to compile this time too. Just a little quick proof of concept to understand how the endpoints and the routing works with the node MCU. Okay, so I am going to update our little script here. Oops, I need to close the serial port. The serial monitor, rather. So if you like what we're doing here, this little project, you know, it's a fun little thing. It's kind of it's a multi-episode project, kind of crossing over a bunch of different domains. Where in previous episodes we've done some coding, we've done some 3D design, some 3D printing, as well as writing some music. This is kind of crossing over all of these together, right? Because 3D scanning, 3D printing the fingers. Doing the coding here with some hardware stuff, and then in the end, because of, you know, music theory things we talked about before, we're gonna have the code write some output that'll cause the motors to move, to push the fingers to play some music. So this little project is, like I said, kind of encompassing everything that we've talked about over the last few episodes, or you know, yeah, most of the episodes, I guess, right? It's sort of all encompassing here. If you like what's going on here, please, you know, like these videos, subscribe to the channel. Live every Thursday from 8 p.m. to 10 p.m. Central Time. And, you know, just having some fun. Welcoming any feedback, criticism, you know, whatever. What should I do differently? Some other new stuff coming up with some woodworking and some other coding stuff and other hardware projects and 3D printing and whatever. So, you know, if you're enjoying this, please, you know, like and subscribe and share it, social media and whatever, and let me know what you think. So we're done uploading there. Connect to the serial port. I'm gonna go ahead and hit reset just because so configuring access point, API IP is 42.42.42.42. I need to reconnect to Piano Player 2. I need to connect automatically. Password should be saved in there because it's the same one as before. And Windows 10 is going to take its time connecting. Now, obviously our little sort of proof of concept interface here isn't going to be displayed when we connect. But this is testing that the what am I trying to say? Our understanding of the routing and the endpoints is as we expect. So 42.42.42, this guy's here. If I go to slash single, I forgot what it was. Is it single? Yeah, single. You did not provide a note to play. question mark note equals 3. You played the 3 note. Note equals E. You didn't provide a note to play. Okay, cool. So all that's working as expected, which is good. So understand how the routing works, how the endpoints work, how to handle the arguments, and it's going to be possible to do a demo interface with the different URLs that'll do the callbacks appropriately to send, you know, whatever we need to, and we can get information back. Cool. So I like this progress tonight. I feel like we're in a good spot now with some understanding of how the device is working, the main brain of our machine. So next week, next Thursday, 8 p.m., we will be moving on to the next section, where we'll actually work out sort of the figure out the interface, work out the endpoint calls and all that stuff for, you know, a handful of things, maybe a couple of a scale run, a few little melodies, some chords, whatever, and figure out how we plan on interfacing between the Node MCU and the Arduino, probably over hardware serial, maybe using a bit mask, not really sure yet. We'll figure it out next week. Yeah, so I think we had some pretty good progress here. And once we get the control interface sort of worked out, we'll get hooked up with the Arduino, hooked up with some motors, and then hooked up to the fingers, and, you know, maybe another 3 episodes we'll have some workable prototype going on. I don't know, we'll see. Thanks again for hanging out tonight, or for checking out the video. If you're now watching this in the future, my future, your present, but now it would be your past, because we're at the end of the video. Time. Thanks for checking it out. Please, like I said, like, subscribe, share. Let me know your thoughts, comments. Is this dumb? I don't think so. It's kind of fun, but maybe, you know. Once we get this worked out, what else could it be used for? Is it, you know, some armature for a pick away from playing the guitar? Because if it's already the fingers pressing down on something, like, it would be like the fingers pressing on the frets. Is it, you know, I don't know. What other applications can you think of some Wi-Fi controlled set of 3D printed hands doing? Appropriate things. Cool. Well, thanks again, and I'll catch you next week, same time, and yeah, this is good progress. Much better progress than 2 episodes working with a 3D scanner. But, you know, these things happen. This is live for a reason. Partially because I'm lazy and don't want to edit a whole bunch of video after shooting stuff. Also, it shows the real process behind figuring out something like this, right? You know, running into obstacles and working through them, and so it took 4 hours to figure out the scanner instead of 2. No big deal. You know, fun stuff like that. Learning things, having fun, hanging out. So, thanks again, and talk to you later.
Here we go.